Well, I am going to continue talking to you Chemistry 20s about three very important words that describe what happens to a substance when it's placed in water. Does it dissolve? Does it dissociate? Or does it ionize? So to summarize, so far we've talked about things that are soluble in water are able to dissolve. Ionic compounds, not only do they dissolve in water, but since they're made of ions, they make ions in solution. We say they dissociate. Acids are special because they're molecular compounds. They should stay as molecules, right? Here's an example, molecular compound, but wait a minute, because it is an acid, because it has hydrogen ions, it is able to ionize. It is able to make ions in solution. So it starts as a molecule, but makes ions in solution. So we would write ionization equations for our strong acids. Now notice there's two types of acids. There's strong acids and also weak acids. So on your data booklet, on page 8 to 9 of your data booklet, and I'm just going to pull that up in a second here. It's sideways, I know that, I apologize. But when you look above the hydronium ion, this is a list of all of your strong acids. These guys are able to react with water and make ions. They ionize. Everybody listed below here and on the next page into page 9, these guys are the weak acids. And so we are going to treat these two guys different, right? They do different things in solution based on whether they are a weak or a strong acid. So here is our examples. And again, we say that strong acids like hydrochloric acid and sulfuric acid, these guys are going to form ions in solution. They ionize. Weak acids do not ionize very much. They're only going to dissolve. So here's a weak acid. And if you look on the data booklet, you're going to find that he's below that hydronium ion. And we see to start, he's a molecule, he's liquid, but he dissolves. He becomes aqueous, but he does not ionize very much, not like a strong acid does. Okay, so this is a special ability that acids have. Now, not to say that weak acids don't ionize at all. They do a little bit, just not nearly as much as a strong acid. So here's what happens with a strong acid. Here's our little acid molecules. We start as molecules, we put them in water, and they break apart. Immediately, we've got hydrogen ions, and let's say this is HCl, chloride ions. So they've broken apart, like 100% break apart. They 100 completely percent ionize. Here's a weak acid, somebody like acetic acid that we just saw. So is he going to ionize? Yeah, a little bit. Yeah, he's going to ionize a little bit. So you see that he does form some hydrogen ions, and he will form some negative ions, some acetate ions, but not very much, right? Most of the acid stays as molecules. So we know that when you dip a conductivity meter into an acid, the conductivity meter glows. With a weak acid, it won't glow as much because it doesn't make as much ions. A strong acid, that conductivity meter, it's a very strong electrolyte. It's very strongly conductive because it makes more ions in solution. These guys are not as conductive because they don't make as many ions in solution. Okay, so that explains what happens to ions. Ions are going to be able to, what happens to acids. Acids will ionize. So you guys have learned about dissociation. That's ionic compounds breaking into ions. They're already made up of them. And when you're writing out a dissociation equation, I just want to remind you that when you're doing that, not only do you need to check the atoms, but you need to check the charges. So on the left side of the equation here, on the reactant side, count up how many NAs do we have? Well, there's one NA there. And on the product side, how many NAs do we have? Well, a coefficient, there's no coefficient, so we know there's one there. And how about CLs? Well, we just assume there's a coefficient of 1 there. And the CLs, it's a negative, but there's just one of them. So we're balanced, right? One sodium, one CL, one CL. Now we also have to check charges. Remember that any compound is neutral. 0, there is no charge. Now on the product side, we have a positive cation and a negative anion, and positive 1 and negative 1 add up to 0, so our charges are balanced. So every time you are writing a dissociation or an ionization equation, you have to make sure that you are balancing out not only the atoms, but also the charges so that they are equal on both sides of the equation. Little reminder here, and this should not be any news to you. This is something you've known since Science 10, that bases, the reason why they are basic is because they have hydroxide ions. And so we know that when you dip a strip of litmus into them, the red litmus goes blue. Acids, on the other hand, why are they acidic? Well, because they have hydrogen ions, right? And that's, we just talked about, they are able to ionize, and that makes them special. And it's the reason why the blue litmus turns red in an acid solution. Neutral substances like sodium chloride or a neutral molecule like ethanol, those do not produce hydroxide or hydrogen ions in solution. So blue litmus stays blue, red stays red, and we call them neutral. They're not going to change the pH of the solution. Okay, so you guys can read through here, and really I've just talked about this, right? Why is an acid an acid? Why is a base a base? Why is a neutral a neutral? You can read about energy changes, endothermic and exothermic. You've heard these words before as well, right? Giving off energy is exothermic, gaining or absorbing energy is endothermic. But mostly we're focusing on what happens to solutions in water. What is going on when you are placing a solution in water? Does it dissolve? Does it dissociate? Or does it ionize? So again, you can look at your data booklet to find examples of strong acids and weak acids. And you're looking at, are they above or below the hydronium? And then we talk one more time here again about what happens with molecular compounds. Well, if the molecular compound is nonpolar, it will dissolve in other nonpolar solvents. If it is a polar molecular compound, it will dissolve in another polar solvent, like water, for instance. So we call that like dissolves like, right? They're dissolving in similar substances, nonpolar and nonpolar, polar and polar. So ammonia, hydrogen peroxide, all these guys are polar compounds. They all have hydrogen bonds in them. So if you're writing out their equation for, they don't dissociate, they don't ionize, they just dissolve, they stay molecules, but you're going to change the state. This fact that it becomes aqueous here means that it is able to dissolve in water. On the other hand, guys like methane and propane, gasoline, octane, they're not going to dissolve in water. They do not become aqueous. They stay as a gas. So you would leave their state the same and not change it. They're not soluble in water. Okay, so here's another good little summary that just, goes through this. Essentially, it's these three words again, right? Does it dissolve? Does it dissociate, or does it ionize? So molecular compounds are just going to become aqueous. They dissolve. Ionic compounds and bases, of course, bases are ionic compounds with hydroxide. They both dissociate. They make ions in solution. Whereas acids are special because they start out as a molecule, but then they make ions, and so we say they ionize. So you guys are going to get some practice writing out these different equations. Does it dissolve? Does it dissociate? Does it ionize? And to help you, I have also put up an attachment called Does It Dissolve? It's a little concept map where you have to kind of follow through the steps. Well, is it molecular or ionic? Well, if it's ionic, just go onto your solubility table. And if it's soluble, it's an electrolyte. It's going to break into ions. If it's not soluble, you keep it as is. Whoa, what about molecular compounds? They're not on that chart. That chart in your data booklet, your solubility table is only for ionic compounds. So what happens if they're molecular? What do you do? Well, you've got to look and think back to that bonding unit. Are they going to be soluble in water or not? Well, look at what forces they have. Are they polar? Do they have hydrogen bonding or not? And that's going to decide that whether they are going to be soluble or not. They are not able to dissolve in water. And then lastly, What about acids? Well, we've talked quite a bit about acids. They are special. And so you have to decide, is it a strong acid or is it a weak acid? How do you do that? You go into your data booklet, pages 8 to 9. And if it is a strong acid, you break it apart into ions. It's an electrolyte. It ionizes. If it is a weak acid, it doesn't ionize completely, so you just leave it as an aqueous molecular compound. Okay, hopefully you'll be able to now complete this booklet, and I'm going to have one more video for you guys this week, and that video will be on writing net ionic equations. And then after that, you'll be able to write your assignment for the week. Have a good rest of your day, and we'll chat with you later.